Alright, nerds, so let's talk about density. So by the end of this, we should be able to understand how we would measure and calculate density, and we'll know we can do this when we can prepare an activity or plan an activity where we measure the density of an irregular shaped object. So what is density? Well, I mean, really, when we're talking about how dense something is, we're talking about how much mass we have in a certain volume. Okay, so what that means is we're talking about mass per unit of volume. Okay, so grams per centimeter cubed. Another way to write this, by the way, if you want to impress your maths teachers, and your science teachers actually, is like that. You can get rid of that slash, so it's grams per centimeter cubed. What we're really talking about, though, on a molecular level is how tightly the particles are packed together. And that's a big deal. So we want the particles packed together as tightly as possible if we want to say something's really dense. If we want something that's not dense or not heavy, so heavy is a measure of denseness, by the way. If we want something that's not heavy, so it's light, we want the particles with lots of space in between them. So the more tightly the particles are packed, the more dense it is. Density is mass over volume, which makes sense because it's grams per, which means over, centimeters cubed. And we see that with D equals M over V. That's the equation you need to remember. And another little tip to remember here is that 1 centimeter cubed, which is our standard unit, the standard unit we'll use is centimeters cubed, is equivalent to 1 milliliter. Now, density of regular shapes. This is the straightforward version. So here we have a cube. It's a nice cube there. It's not poorly drawn at all. And it's 1 centimeters wide, 1 centimeters high, and 1 centimeter deep. Okay? And it's been sat on the set of scales right about here. And we can see that it weighs 1.5 grams. So the first thing we're going to do is we want to measure the volume. Okay? That's length times breadth times height with a cube. There are other ones depending on what you're dealing with, but we'll talk about cubes because it's the easiest. Then we weigh the object. We measure its mass. And then we calculate the density using D equals M over V. So let's check that for this one. So the volume is really simple. It's 1 centimeter times 1 centimeter times 1 centimeter, which gives us 1 centimeter cubed, or 1 milliliter. The mass is 1.5 grams. We put it on the nice set of scales there. Bang, gives us a number. Make sure you tear it first. And then we go D equals M over V, and that gives us 1.5 grams divided by 1 centimeter cubed, which gives us 1.5 grams per centimeter cubed. Or, because we're trying to be fancy, 1.5 grams per centimeters cubed. Now, let's have a look at the density of an irregular shaped object. So an irregular shaped object is one without standard measurements. Like it's got lots of little shapes put up together, and it's sort of, like a rock is a good version of an irregular shaped object, or an iceberg. So before we can measure this, we need to remember that 1 centimeters cubed equals 1 milliliter. And because this is true, we can just use the displacement model, where we will drop it into a known volume of water that we can measure changes in volume. And the change in volume, the displacement, is the volume of that object. Right. So it's not too complex. And I hope you can see applications of that in the lab. If you have any questions, put them in the comments below. Thanks for watching. We'll see you next time. Bye now.